Hello students, how are you? Hope you are doing well. Now the question is, find the expression for the capacitance of a parallel plate capacitor of plate area A and plate separation D when part 1 a dielectric slab of thickness small t and part 2 a metallic slab of thickness small t where t is less than small d are introduced one by one between the plates of a capacitor. In which case would the capacitance be more and why? So this is the particular problem. So here is the diagram corresponding to the given situation. These are the plates, two plates having the charges as plus q and minus q respectively. In between there is a dielectric slab of thickness small t and the air sections. These air sections, remaining air sections are having thickness of d1 and d2 respectively. The externally applied electric field is E naught. The induced electric field, these are the induced charges minus q and plus qi, minus qi and plus qi are the induced charges on the respective faces of the dielectric, and correspondingly the electric field due to this induced charges is E sub I. E sub I is the induced electric field due to the induced charges. So the net field inside this particular dielectric is given by E naught minus Ei. This is the net electric field inside the dielectric. V1 and V2 are the respective potential in the air, in the section of the air, and V sub T is the potential in the dielectric section. So this is the situation. So we can say that the total voltage is the sum of V1 plus V2 plus V sub T. Now what is V1? V1 is basically from this formula E equals to V upon D. From this particular formula, V1 is the electric field multiplied by the distance. So the electric field in this section multiplied by distance. So electric field in this section is E naught and the distance here in this case is D1. Similarly, V2 is the potential difference in this air section. So this is equal to E naught into D2, and the remaining section is having the voltage of Vt, and Vt is equal to the electric field here. So the electric field here is E times the thickness. The thickness is T. The thickness is T. So this is the expression here. So from this expression we can write this E naught D1 plus D2 plus E into T. This is the expression here. Now we know that for the particular relation between the electric field and the surface charge density, this is the expression. Electric field is equal to the surface charge density upon the permittivity of free space. So this value comes out to be Q upon A times epsilon naught, where Q is the charge and A is the area of cross section of the plate. So this is the expression here. Now this E is basically E naught by K. This E is basically E naught by K. So here we can put the value as E naught. D1 plus D2 is nothing but D minus T. This whole length is D. This is D1, this is D2, this is T. So D1 plus D2 is D minus T. D minus T. And E is equal to E naught by K into T. Now this E naught comes out to be common. So we get this value as D minus T plus T by K. And E naught is nothing but Q upon A epsilon naught and multiplied by this value D minus T plus T by K. This is the expression of V. So from here we get the value of C as C is basically from the expression Q equals to CV. C is Q upon V. Now Q upon V from this expression is Q upon V is A epsilon naught upon D minus T plus T by K. So this is the expression corresponding to the capacitance of a capacitor having a dielectric of thickness small t. This is the final expression here, where K is the dielectric constant here. So this is the expression for the first part, that is the part in which there is a dielectric of thickness T. C equals to A epsilon naught D minus T plus T upon K, where A is the area of cross section, epsilon naught is the permittivity of free space, D is the distance between the plates, T is the thickness of the dielectric, and K is the dielectric constant. In the second part, it is asked that the metallic plate is inserted instead of the dielectric. So for the metal, we know that K is tending towards infinite. K is infinitely large. So we can say that C equals to A epsilon naught upon D minus T plus T upon infinite. Now T upon infinite is 0. So this comes out to be epsilon naught A upon D minus T. So this is the expression for the case where there is a metal, the second part. Now it is also asked that capacitance is maximum for which case? Capacitance is higher for which case? Whether for the dielectric or for the metal. Now you can compare these two expressions. Here the term is T upon K and this term is missing here. This term is in denominator and this is a positive term. So it means that the denominator is large in the case of dielectric and the denominator is small in the case of metal. So when the denominator is small, it means that the capacitance in the case of metal, is greater than the capacitance in the case of the dielectric. So this is the solution of this particular problem. So hope you understand the solution. Thank you.